So we reach to a place ambayo inatuambia conservation of linear momentum. First, the law of conservation of linear momentum states that if two or more bodies collide against one another, final momentum after collision is equal to the initial momentum before collision when the system is isolated. It means when there is no external force that is applied. Mv is equal to mu. So kwanza tutaanza zile cases ambazo tumezoea, sawa? Kwa mfano, when a hunter fires a bullet of mass 10 kilograms with a velocity of 400 meters per second from a gun of mass 5 kg, what is the recoil velocity of the gun? So tunajua kwamba ni summation ya initial momentum sana summation ya final momentum. So initially when the gun was not fired, the bullet and the gun zilikuwa at rest, ndio. Lakini after firing, kwa sababu hapa velocity ya recoil, it means gun ile unajua ukishoot pap gun kama inarudi nyuma hivi, sawa, ndio recoil velocity. So we know when you fire a bullet initially, the initial momentum was 0. Lakini the final momentum kulikuwa na velocity fulani ya recoil ya bunduki na velocity fulani ya risasi. Kwa hizi ni final momentum, initial momentum. Hii ni vitu ambavyo tunakumbuka, I believe, ndio. So we have the mass of the gun, the mass of the bullet we have, and the velocity of the bullet. So eventually you can solve for the velocity of the recoil of the gun. Okay, yeah. So negative, you should get negative here. It means that it is recoiling, it is going in the opposite direction. Also it says if the hunter is standing on ice, then what velocity he along with the gun will acquire? The mass of the hunter is 75 kg. So saying that it is in ice, it means usianze kuweka friction na nini, assuming that there is no friction, kwamba ile recoil tu ata recoil yeye na gun yake bila kuwa opposite. So it means the same thing, lakini kwenye mass hapa utaweka mass ya gun na huyo mtu, sawa? Kwa itakuwa ni total mass ya gun na huyo mtu, ambao mass ya gun ni 5, mass ya huyo mtu ni 75. Kwa the total mass itakuwa ni 80. Ndio hapa alichofanya hapa 75. Kwa itakuwa the same. Hii ni vitu ambavyo tulikuwa tumesoma leo. Nakumbushia tu, a shell is that kilogram flying at that meters per second. When it explodes, its one part of 18 kilograms stops, while the remaining part flies on. What the velocity of the later? So we know what initial momentum. Cha kwanza unaandika initial momentum is equal to final momentum. Hiyo ndio principle of conservation of momentum. So initial momentum, because it was just one shell na velocity yake, so ilikuwa ni mass ya 30 na velocity yake. Finally ka split into two parts. Part ya kwanza ambayo ili stop, okay, part ya kwanza ambayo ili stop maana yake ilikuwa haina velocity, ilikuwa ni 0. Part ya pili ambayo ilibaki kutoka 30 na 18 zimebaki 12. Part ya pili ambayo ilikuwa na 12 ika move na velocity kiasi gani? So unaweza kuona hapo 30 ni hiyo, 18 ili stop, 12 na velocity yake unaweza kutafuta velocity ya pili. Same tu mfano unaweza kaangalia kwa revision. Okay, a hunter has a machine gun that can fire 50 bullets to the velocity of that. So initially kuna kuwa na momentum ya 50 times 150. A 6 kg tiger springs at him with velocity of 10 meters per second. How many bullets must the hunter fire per second into the tiger in order to stop him in his track? It means momentum anaokuja nao tiger lazima hiyo ni sawa sana momentum ya bullets zinazoenda kwa tiger, so that when they collide they stop hapo. Sawa? Kwa sababu it means initial momentum, this is for the gun U1, na initial momentum ya tiger after they collide must be equal to 0, because we want to stop the tiger na bullets they stop together. So eventually momentum ya huyu lazima sana momentum ya usema they move in opposite direction. Kwa hiyo anakuja na wewe na opposite. So we just equate momentum ya tiger na momentum ya bullets. Sasa ka bullet kamoja, so the total momentum inabidi iwe times n number of bullets. So n times m1 times, kwa n ni number ya bullets fulani. Ndio hicho alichoweka hapa. Times velocity ya bullet ni sawa na momentum ya tiger. So eventually you can solve for n na kupata value yetu. Etc. Angalia huu mfano hapa na see if you can recall. So one among good applications of conservation of momentum is what we call ballistic pendulum. Inakuwa ni kama kakitu kamening'inizwa afu na kapiga hivi, sawa, kanaanza kuoscillate. So ni ballistic pendulum. So ina application nzuri sana na ya conservation of momentum. So consider a bullet labda ilikuwa ina move hapo, na yenyewe kuna kibao kimekuwa kimening'inizwa hapo. So initial momentum mwanzo, kwa vile huyo anakuwa stationary, anakuwa hana momentum. So momentum inakuwa only due to the bullet, mb1 ni sawa na total momentum. So there are two conditions here. It's either risasi iingie ndani ya ubao zianze kumove pamoja, au risasi iingie ndani ya ubao afu itoke. Kwa kesi ambayo nimeonyesha ni risasi imejiattach kwenye ubao, so they move together perfectly in elastic collision. So the final momentum, because they move together, will be the total mass times the total velocity ambazo zitakuwa zina move pamoja. Lakini kama ingekuwa ni ubao tu afu inapita, then momentum hapa final ingekuwa ni mass ya body times velocity ya body plus mass ya bullet times final velocity ya bullet. Ingekuwa hivyo, unazitofautisha na makini. As long as they are attached and disembedded, they move together. So there are two things we always use kwenye hii condition. Kuna conservation of momentum na conservation of energy. We use them together kawaida kusolve haya maswali. So from the conservation of energy inatusaidia kupata expression ya final velocity, that v is equal to 2gh square root. This is change in h, the h which will rise after they collide. So where does this come from? This comes from the conservation of energy, that on the moment of collision, the kinetic energy that they possessed in total will be lost, na itakuwa converted kwenda kutengeneza potential energy ambayo itawasababishia wa raise distance ya change in h. So to compare kinetic energy lost of the total, hapa nimeandika mb lakini I meant the total of the total system times velocity initially. So the kinetic energy that they lose is equal to the kinetic energy that they gain. So eventually mass na mass ita cancel, utabaki na v square over 2 is equal to gh. So kama tunapata v square is equal to 2gh, ndo square root unapata v is equal to 2 times g times change in h. Kwa this tunaitumiaga kwenye kutafuta the final velocity. So as you can see hapo inatusaidia kupata final velocity. Another thing hapo, unaweza kuulizwa utafute hii angle. Remember hii system iko namna hii, sawa? Hii kamba ita raise distance fulani, ndio ita raise distance h, sawa? Kumbuka kutoka hapa mpaka hapa mwanzo ilikuwa ni kamba, okay? Ilikuwa ni kamba hii yote, sawa? Ime raise distance h, kwa hii ni theta. Kumbuka huu ni urefu wa kamba pia ule. So tukiresolve hiyo displacement hapa tunaweza kupata L, kwa sababu tuna cut across, kunakuwa L cos theta. Hii triangle yetu inaanzia hapo, inakuja kwenye hii angle hapa, inakuja kwenye huo ubao hapo. So we have L, then huku kama tunataka hapo mpaka hapo tutoe aka ka region ambako ni ka h. So you can see that L cos theta inakuwa only that part hapo. Still kutoka hapo mpaka hapo ni L. Okay, so we came to realize that this extra distance ni h. So tukichukua L minus L cos theta, tunaweza tukapata hiyo change in h, kwa sababu kama hapa mpaka hapa ni L cos theta, resolve hii ni L cos theta hapo mpaka hapo, sawa? Lakini kutoka hapo mpaka chini kabisa ni L. So aka ka distance kaiko baki ni L minus L cos theta, tunabaki aka distance h. Kwa tunaweza tukatumia pia kama tuna length na tuna change in distance h, tunaweza tukatumia kupata angle, au kama tuna angle na hizi length tunaweza tukatumia kupata change in distance, tukarudi reverse way. Anyway, the point is just understand the relations between the angle na hizo distance. So we have an example here. We have examples here that maneno ni hapo madogo kidogo. I hope mnaona vizuri. 12 kg rifle bullet is fired with speed hiyo hapa. Ndio hii hapa. 12 grams bullet na velocity hiyo hapa. Into a ballistic pendulum with mass 6 kilograms. Suspended from a cord 70 cm long. Compute the vertical height through which the pendulum rises, initial kinetic energy of the bullet and pendulum immediately after the bullet becomes embedded. This word is very important. So we know initial momentum is only due to the bullet is equal to the final momentum, because they embedded, they move as one system. So the total mass ya bullet ambayo ni 0.12 times mass ya pendulum ambayo ni 6, ndio initial kwa tunapata value ya final velocity na kwa hiyo hapo. So eventually from this formula here, final velocity ni sawa na square root ya 2gh. So eventually we know kwamba change in h from here, we know change in h is equal to v squared divided by 2g. So if we take v square ambayo tumepata hii hapa 1.52 squared, hii hapa 1.52 squared divide by 2 as a half here, divide by 9.8 create 9.8 hapa, tutapata h 0.118. The initial kinetic energy of the bullet and pendulum immediately after the bullet becomes embedded in the pendulum. So you know that they move together. Okay, they move together because after collision, it means immediately after collision they gain a velocity of 1.52. okay, but they are together now, so they move together. So moving together, it means the total mass in the formula tutatumia ya total. So finally of that. So another example is here. It's exactly the same way. You can try it on your own. Okay, we have another example, but this time does not embed, ina hit na inatoka. Tufanye mfano. You have a 5 gram bullet shot through a 1 kilogram block suspended on a string 2 meters long. The center of mass of the block rises 0.45 centimeter. Find the speed of the bullet as it emerges from the block if its initial speed is 450. Okay, we have initial momentum is equal to final momentum. Initial momentum is only due to the bullet because it's the only one that is moving. So tunabaki na hiyo hapo. Final momentum is equal to separately momentum ya bullet, okay, final velocity ya bullet, momentum ya pendulum, final velocity of pendulum. Putting in the numbers, the values, we have V1F and V2F. They are separate. Notice that we have two unknowns, so we must find V2 first in order to find V1F. Okay, yes, where V1 are the values of the bullets. So you first have to find V2F because tumeshapewa distance ambayo ime raise, so tuzo kutumia principle of conservation of energy tukapata our value kwamba V ni sawa na square root ya 2gh. So if we take 2 times 9.8 times the height ambayo ime raise, which is 0.45, tunapata the final velocity is around 3 millimeters, okay, which is 0.3 meters. So we convert, so we put just 2 times 9.8 times the height. Remember pepe kwenye centimeters, so convert it kwenye meters. So convert kwenye meters ndio utapata kama unavyoona hapo, 2 times 9.8 times ka convert kwenye meters, square root tunapata 0.3 meters per second. Okay, yeah. So getting this value, coming back here, we have this value now. So finally we can finish with that value. Substitute, you get the value. You substitute that value there, then we have V1F as that's the answer. So this is how we do the question in case ikiwa inaingia na kutoka. Okay, So you can try this question on your own. There is no answer here, but I believe it's not a difficult question. Nitakuinterpretia swali. A pitcher is employing ballistic pendulum to determine the speed of fast ball. Sawa, anataka apime kwamba yeye ni pitcher. Sawa, ni wataalamu wa baseball wanafahamu, wale ambao wanarusha mpira. Sawa, yeye aim yake ni kujua ana nguvu ya kurusha mpira unaoenda distance, I mean kwa speed gani. Okay, determine the speed of his first ball. So ameweka 5.3 kg clamp clay hapa, is suspended on a cord 2 meters long. When the pitcher throws first ball aimed at the clay, the ball becomes embedded naingia in the clay and 2 swings up to a height ya 0.1 meter. Change in height is 0.1 meter. If the mass of the baseball is 0.2 kg, use conservation of momentum and energy to find the pitch. So unatoka huku unarudi, sawa, una hii value ya final momentum, kwa unatafuta ya initial. So you can try that on your own.